Hi everyone, this is Delbert speaking, and in today's class I will talk about the contract of peak demand electricity between utilities. This is the most important class that we will have because I will present the rules used in Brazil, applied in Brazil, to define the contract between transmission and the distribution companies. So it is important because I'm not sure if the same rules is applied in other countries. So it's important to pay attention, take notes, bring your questions, because we will solve this problem in October. The agenda of this class is an introduction to the Brazilian power system, the roles for peak demand contract. These roles are defined by the regulator of the system, which in Brazil is ANEEL. ANEEL stands for Agência Nacional de Energia Elétrica, which is in English National Agents of Electricity. And the last part of this presentation, I will present the challenges to compute the peak demand contract, which is the objective of the activity. So starting by the introduction to the Brazilian power system, we have three, we can divide the Brazilian power system in three parts, as in other countries. The first part is the generation. Particularly in Brazil, we have more than 8% of the generation of hydropower plants. And then we need the transmission system to transport the energy from one region of the country to another region. And as you know, Brazil has a very large territory, so we need a very large transmission system. And then at the end of this system, we have the consumers, industrial, residential, and commercial. The problem that we need to solve is what is the value of the contract between the transmission and distribution, and this value is given by the power flow through these both systems. So to define it, let's study the roles for peak demand contract between utilities. So suppose you have a transmission system. Here we have a generation represented by this generator, and then we have a transmission system represented by this line, and the power flow to feed the loads is given by this variable Fm, which is the power flow, the maximum power flow in the month M. And then we have the distribution system. So this power flow over the year, here we have the maximum power flow over the year, or the power flow over the year, will define the contract between the transmission and distribution system. Okay, so continuing, the contract we will call M. M is the value of the contract in megawatt, which is defined, which is computed by the distribution system and agreed with the transmission system. So when we define the contract M, then we can compute the cost of the distribution system to the transmission system. We will divide these costs in two parts: the non-recoverable recoverable costs and recoverable costs. We call recoverable costs because we can use this value after to put in the tariff of the consumer, and the non-recoverable costs we can't recover it by the tariffs for the final consumers. So in order to compute the recoverable costs, we have the contract M, and we have the M multiplied by the tariff associated to the transmission system. So when we multiply the M by the tariff for each month of the year, then we have the costs associated to the recoverable costs. Okay? The non-recoverable costs, on the other hand, is computed when the power flow in the frontier of both systems is above the contract. When the power flow is above the contract, you need to compute the non-recoverable costs. And the non-recoverable cost is computed by the sum from 1 to 12 of the maximum value between 0, I mean it can be negative, so 0 and this expression Fm minus M, big M in capital letter. So when it is positive, which is the case of this blue area, we need to multiply it by the tariff of the month M, and then we compute the cost. So this value Fm is the peak demand, the peak value of the power flow in the month M. You don't need to compute for each power flow over the month. You need to pick the maximum power flow and then apply this expression. Okay? So continuing the costs associated to the contract, when you have a month where the peak is above 1.1, the value of the contract, then you will have a penalty. This penalty is called the penalty for under contract. Then you will face a penalty because you didn't plan well the system. And the value of the penalty is the sum from M equal to 1 to 12, and the maximum value between 0 and Fm minus 1.1 M multiplied by 3 times the tariff. So this is the reason, or this is the penalty associated of under contract. Okay, so until now we have the recoverable costs, the non-recoverable costs, and the penalty associated to under contract. But to avoid the under contract, you can think that you can put the contract too high and then you can avoid it. You only will have, for example, in this case, you only have recoverable costs. To avoid this, because it's a problem for the transmission system, because the transmission system uses information to plan the transmission system. So you don't want a contract too high. So in order to avoid it, there is a penalty for over contract. So if the contract is too high, in this case if the power flow through the frontiers is below to 90% of the contract, so you will face a penalty. And the penalty, the value of the penalty is 12 multiplied by the maximum value between 0, which means that this value can't be negative, and this expression. So here we have 0.9 m, big M, minus the maximum power flow over the year, which is in this case this point, multiplied by the tariff. So you will have a cost of 12 times the tariff if you have this over contract. Okay, so it's important to avoid this over contract as well. So we have 4 costs involved. We have the recoverable costs, we have a non-recoverable cost, we have a penalty for under contract, you have a penalty for over contract. The challenge for this problem, or the challenges to this problem, is associated to the forecast of the power flow, because you need to define the contract ex ante, which means that you have an historic data of power flow, and before the power flow for the next year, you need to define the contract. So in this case, you need to make a forecast or a prediction of the power flow for the next year, and then you define the best contract. You don't know what will happen in the future, but we have tools to think about how to solve this problem. Additionally, we have the losses. The losses in the distribution system should be computed with the loads of the system, and then the sum of the loads and the losses will give the power flow in the frontier of the system. So we will need to face the following problems: to forecast future scenarios of peak demand or power flow, to consider all variables involved in the process, in this case losses and the loads, and at the end to compute the best contract. This is the problem that we will need to solve. For more information about this problem, you can see it in the Agência Nacional de Energia Elétrica. This is a resolution available on internet. I recommend you to download it and to study it before our activity. Okay? So in the next class, we will talk about how to solve the problem by using the tools that we have available today. So see you in the next class.